Okay, good morning, everyone. Great to see you on a beautiful day again outside. Weather's been really nice this last week. Before we get started, does anybody have any questions about anything? Okay, if not, then just for a couple general announcements, remember that the first homework assignment covering our GPS unit is due Monday morning. I believe we said 8:30 would be the deadline when class starts. So please make sure you get it turned in before then. If you have any questions on any of the homework problems that are maybe a little bit general, please remember to post them to the Blackboard discussion board, and either me or one of the TAs will respond to you quickly. You're also certainly encouraged to respond to each other's questions, but one of us will also weigh in just to make sure everything's good. Question?
So you want it in a PDF, right?
Yes.
You can handwrite it
Right. Okay, so that's a great question. So yes, the homework needs to be turned in as a PDF. If you want to handwrite the pages, that is completely fine. Just please make sure your handwriting is legible, just so that it makes it easier for us to grade it. If you've got a steady hand and a good camera, a picture is fine. What's usually more reliable is taking it to one of the scanners around campus. I know there's one in Javits, there's several in the library, and there are probably a couple at sync sites as well, and just scan the documents in. That usually produces a better image that's easier for us to read. Because sometimes, like when you use your phone, if the flash is on, sometimes it gets a little bit bright and it's hard to read parts of the pages, or if you've got it on a weird angle. Also, please orient your pages correctly. Up is up. That also makes it easier to grade. If part of it's typed and part of it's handwritten, that's fine. Just make it clearly labeled so that we know what we're looking at when we're looking at it. Again, I'm not going to get super picky on this.
I know that you said don't make the work look really messy.
Yep.
If some stuff is crossed out, is that okay?
If a few things are crossed out, that's fine. But just again, the reason why I sort of put that in there is when large things are crossed out, it sometimes makes it hard for us to follow what's going on. Again, the easier you make it for us to grade, the quicker we can get the responses to you. Because there's 3 of us grading and 115 some of you. And that's why I request that.
I know I didn't really want to use a pencil because I didn't know if it would scan right. Is using a pencil okay?
So pencil, my experience, if you're going to use pencil, actually like taking out a phone and like taking a picture usually doesn't work that well because the contrast isn't good enough. If you go to the scanners, you can usually play with the options and tell it to really up the contrast. Just take a look. So like when you do the scanner, it'll scan it in and it emails you a PDF file. Just look at it first before you submit it. And if it's a little bit light, you can go back to the scanner, sort of up the contrast a little bit, and it usually works okay. But yeah, pencil, sometimes you have to play with the settings a little bit. Black or blue pen usually works just fine. Other questions? Okay, and so then remember, also, so there's the homework due on Monday. Bring any questions about the homework. I'm happy to discuss them Monday in lecture. Also remember then a week from today, next Wednesday, we will have our first quiz at the end of lecture covering the GPS unit. I know there are quite a few equations that we had. I don't really want you memorizing any of these things. I don't think that's a particularly useful way for you to spend your time. So I will post over the weekend, well, probably even later today, a sheet of possibly useful information for the quiz. So I will provide that for you on the quiz. You don't need to memorize anything on it. I'm not really going to give you any context. There's just going to be the equations, sort of maybe the coordinate system stuff. But take a look over that when you're studying, when you're working through the rest of the homework assignment, to just know I will give you that information on the quiz. You don't need to memorize it. Otherwise, the quiz is closed note. Do please bring a calculator for the quiz. So long as it's not Wi-Fi enabled, which is to say you can't use the calculator on your phone. Okay? Other questions or anything before we move on? Okay. So then, the first thing we're going to do today is sort of take a break from the GPS unit, and I want to come and talk about the term paper. Dun, dun, dun. So you'll notice if we go over to Blackboard in the assignments tab, there's now a whole folder dedicated to the term paper, and there are a couple things that you can see. You can actually only see 2 of them right now, but there are 3 things there. The other one will become visible soon. And what I want to do is spend a little bit of time today talking about this stuff and answering any questions that you have. Because as you remember from a few weeks ago, the term paper is a really big component of your final grade. Simply because I really regard the term paper as sort of the capstone element of this class. I know if you've taken other AMS courses, you probably think the final exam is the capstone. In this class, the term paper is really the big ticket. And so basically, what I want you to do in the term paper is to sort of duplicate in a way what we're going to be doing all semester in lecture. So we're now basically at the end of the GPS unit. We've got that big example that I posted at the very end of class last time that we'll work through in the back half of class today. But other than that, we're done with the unit. And so you've now seen sort of how this structure works, where we can start with what is the technology? Why did we invent it? How is it used? What are some of the limitations? And there's some of this historical context, societal context, whatever the case may be. We then sort of reached that question, that sort of key question that we wanted moving forward to sort of guide our discussion, which was to say, how many satellites do you need to see to determine your position? Was that the only question we could have asked about GPS? No. There are millions of others. We can be as creative or as dull as we wanted to be in choosing that question. But that question then guided our discussion into talking about some great math concepts like trilateration and triangulation. Some other math concepts we saw. We saw a system of equations. With regard to the GPS problem, what we were really looking for was, was there a unique solution to that system of equations? Because that's how we can uniquely determine our location from all of that information. And then to put it all together and to bring in latitude and longitude, we introduced one other math concept, which was coordinate systems, spherical coordinates, azimuth and polar angles. All of those would be valid answers. And so then what we did is, again, we had sort of what is that technology, what are these math concepts, and then at the very end we can pull it all together to sort of see how it all works. What I want you to do in the term paper is to basically repeat that process, but now for technology that's of interest to you. Okay? There are a couple exclusions. Number one, you are not allowed to pick a technology that we will cover in lecture. So please take a look at the syllabus before you make your choice. Search engines are off limits, sorry. Pretty much anything related to a computer, saying I want to know how a cell phone or a computer or something like that works, also probably off limits. That was a very, very common response. If you remember on the survey on the first day of class 2 weeks ago, I asked you what technologies were you interested in. A lot of people said computers or cell phones, and that's cool because starting on Monday, that's what we're going to be talking about. Okay? But the downside is that means that's a no-no on the term paper. And we'll talk about that a little bit more as we work through. So start thinking of a technology, and there's going to be a couple stages that we go through. So the first and foremost big item on the term paper is going to be in the next week. I want you to choose what technology you want to focus on. Okay? There are lots of great answers. Every semester there's at least 3 or 4 that sort of surprise me. I've not seen that one before, and those make for some really exciting term papers. And so what will happen at the end of class today, there will be a, quote, test, unquote, on Blackboard. It's not really a test, but from logistical reasons, I have to make it a test in Blackboard. Log in. There's just one question on it. It's a short answer. What's the technology you want to study? And how do you think you're going to discuss it? Either what do you think your question's going to be, what math concepts do you think you're going to tie in, why do you find this technology interesting? This does not need to be more than maybe 3 to 5 sentences. Okay? But just something real short, and sometime in the next week, please fill that in. What will happen then after it's due, I think I've set it for 8:30 next Wednesday. Again, so you've got a week to do it. I will go through those and give you feedback. For most of you, the feedback will just be as simple as technology approved. Basically, what's going on in previous semesters, I've run into a couple issues where there are a handful of technologies that have proven to be very difficult for students to use to successfully complete this assignment. And we'll talk about some of the reasons why that might be later. But basically, if you choose one of those, I'm going to try to ward you off it, just because in the past it's been a very difficult one. One in particular is telescopes. Every semester there's a handful of students that want to do telescopes. It's a great technology. I have found it very hard to fulfill the missions of this project. And so I'm probably going to try to get you to choose something else. Not that technologies aren't, or that telescopes aren't interesting. It just hasn't worked. Question? Okay, so if you, no. The answer to your question is you will still get 20 points. If you submit something on time next week, you will get the 20 points. So long as you actually answer all the questions. If you just give me a technology, you'll probably get like 10 of the 20 points, because the other question was, what math concepts do you think you're going to bring in? Why did you choose this? So there needs to be some justification, okay? So these are free points. I highly recommend you take them, okay? But that's what's going on. So I'm not trying to sort of go through and say, oh, well, I like this technology, I don't like that. That's not what I'm trying to do, and I typically give you a pretty wide latitude on the technologies. But I just want to make sure you're not picking something too close to what we're going to do in lecture, and you're not picking something necessarily that students have had a lot of difficulty with in the past. That's why we go through this sort of approval and verification. Once that's done, I'll post the results to all of you, and you'll be able to see through Blackboard whatever comments that I left. And at that point, you've got, let's say, I think it's about 6 weeks or so, 7 weeks, maybe somewhere in that range, I don't remember the exact number, to work on writing your paper. That involves doing a little bit of research, that involves putting it all together. And what's going to happen at some point later, there's some important dates down here on the slide. Let me bring those up. So yeah, October 30th. So you're going to have a little over a month. So right around Halloween, the first draft of your paper is due. Remember, I mentioned 2 weeks ago on the first day of class that there's going to be a round of peer review for the term paper. And so what you're going to do is you're going to write up a draft and turn it in through Blackboard, and that's going to get randomly distributed to 4 other students in the class who are going to have about 10 days to read through your paper and give you some constructive feedback. Okay? And we'll talk more about that. At the end of that period, their comments become available to you. So you're going to get feedback from 4 of your peers on what they thought of your paper. Did it meet the objectives? Was it clear? Was it fun to read? Whatever they felt like telling you. You then have about a week to make any revisions that you might want. And the final paper will be due November 15th. Notice, that's also about 3 weeks before the end of the semester. I realize a lot of your classes are probably going to heat up around that point. You're going to have final projects due more towards the beginning of December. Let's get this one done and out of the way. Does that work for most people? Okay. So that's sort of the timeline of how things work. And as we mentioned also 2 weeks ago, the term paper in total will be worth 35% of your final grade in this class. 15% is for this process of going through the revision for meeting all of these intermediate milestones, and then 20% is the actual final draft that you'll turn in on the 15th of November. And again, just to iterate, I just want to say this. These are tentative dates. If these change for any reason, I will announce any changes both in lecture and I will post an announcement on Blackboard. So these dates will not change without notice. Okay? And so the way that this sort of process component is put together, 20% of that, did you submit a technology on time next week? Again, these are free points. I really recommend you take them. When we get towards the end of October, when this first draft is due, basically 40% of that component is regarding the first draft, 15% for, again, did you just submit something on time, and then 25% did we deem it to be a, quote, good faith effort, unquote. We'll talk about what that means a little bit more later on. And then lastly, the final 40% of that process component is did you participate in the peer review, which is to say, did you review the 4 papers that were assigned to you, and did you provide professional, constructive feedback? Okay? The peer review is going to be anonymous, which means in principle you can be an internet troll. However, I will know who you are. Your classmates won't, and internet trolling will not be tolerated, which is to say you will not get full credit if you're a jerk. Okay? So, the last thing I just want to make sure all of you know about, that the Stony Brook does have a writing center. There's a link here, and I strongly encourage all of you to take advantage of it as you're piecing your paper together, as you're working on the different drafts, and take a look at what services they can provide and help you. But do know that that resource is there. Any general questions before we start talking maybe a little bit more through this? Yes?
I don't know if you're going to discuss like some more than, but what's like the ideal size for the term paper?
Okay, so that'll be done there. So the question was sort of what's the length of the term paper? I think for text, this doesn't include references, this doesn't include like a cover page if you want to include that, maybe somewhere between 3 and 4 pages. I think I put in here that there has to be a minimum of 2.5 pages of text. That is the bare minimum to meet the requirements. Sort of on the 4th page is where I anticipate it. Okay, so I don't think this is a particularly long, and that's double spaced. So I don't think this is a particularly long paper, but that's how it goes. Okay, so here's sort of the outline of what I envision the paper doing. Again, this is very similar to how we're going to be running all of these units in class. And so, there's the introduction. What is your technology? Why do we care about this technology? Why did we invent this technology? Maybe some societal background. Some cases this might be a little bit long. Other cases it's going to be fairly short because it's probably fairly obvious for a lot of technologies. Short section on how it works. Just like we do with the GPS, talking a little bit about, well, there are the satellites in orbit. We have the receivers. They use radio signals to communicate things back and forth. Again, it doesn't have to be excruciatingly detailed. Okay, it's a 4-page paper in a 100-level class. I get that. And also I should note, this outline, these don't have to be like rigid sections in the paper. This is more just sort of from a flow perspective, how I envision the paper, how I would approach it. And I think it gives sort of a nice framework. The big thing that then comes up that I really want to focus on is this idea here of this problem statement. And so think of this as basically being that big question that we ask in the unit, where we said, how many satellites do we need to see with our GPS receiver? Okay. The reason why I think this is really key is there are basically two parts of this term paper in terms of the discussion. And if we think to the title of this class, it might seem maybe a little obvious in retrospect what they are. We have applied math and modern technology. So the two components of this paper that we need to discuss are a technology and some applied math. And what the problem statement does, in my mind, is it provides a really nice way to tie the two together. We sort of have, here's this independent discussion of the technology, here's some problem related to it, and here's how math can help us solve it. Usually when you take a look at maybe one of your peers' papers and you see that it seems sort of unfocused or it seems a little bit unclear, that is almost always because the problem statement was either not very well developed or not very clearly stated. Okay? This is really, to me, the part that sort of ties those two sections together and really makes for a cohesive paper. So spend a little bit of time with your problem statement once you know what your technology is going to be. A piece of advice, depending on the technology that you choose, a lot of times sort of the obvious way to approach the problem statement is, here's the technology I want to discuss, here's a natural question, and go. That can work in a lot of cases. Be a little bit leery, and we'll talk about this a moment below, to make sure that the concepts you're going to bring in for math are actually math concepts and not like physics concepts or engineering concepts or chemistry concepts or something like that. We'll talk about that more in a moment. But the other way, sometimes for some of the technologies, it might be a little bit easier in some regards to say, well, here's the technology I want to discuss. Here are some interesting math concepts that I really like or that I want to know more about, and spend maybe a day or two and think, can you come up with a question that connects the two, rather than sort of asking a natural question and then figure out what math concepts can help. You can go either way, but sometimes the more, I find it to be a little bit more interesting to sort of think, what's the math concept I want, and then try to reverse engineer the question to get me there. And sometimes you end up arriving at a less obvious question, which might be a little bit more fun to discuss. Okay? So once we have that, then what I envision the paper doing is sort of then moving in and talking about the math concepts. And again, I want to focus on the idea that it's math concept, which is to say it doesn't have to be, a full-bore, this is the math, and here are all of these equations, and here's how we can solve everything. Math concepts. Okay? And so think about this again, what we had in the GPS unit. What were some of the concepts we saw? We saw coordinate systems. It's a great math concept. We saw, uniqueness of a solution, or of a unique solution of a system of equations. Great math concept. We're going to see a whole bunch of math concepts as this semester goes on. Now, we're going to do some problems with them in lecture because I can help guide through that. Problems and sort of working out something doesn't necessarily need to be part of this paper. If it's relatively straightforward for you to do and you've got the space for it, that's totally fine, but don't think that it's required. Okay? Just because I realize we're a little bit space limited. And bear in mind that the paper is really targeting other AMS 103 students. So I realize quite a few of you have a lot more math than what's required for this course. You might have taken multivariable calculus, differential equations. It's fine to bring in concepts from those, but remember to explain them and use them at a level that is appropriate for this class. Okay? Just to put it in words, what are the prerequisites in terms of math skills for this class? Pre-calc and trig. Okay? So just bear that in mind. And I give sort of here a list of just a random list of different math concepts. Do not think that this is an exhaustive list. There are plenty of others. But I just want to sort of help get your brains going on what we might want to use. And so then when that's done, you can say, here's the technology, here's a problem statement, here are the math concepts. maybe a short discussion at the end of how do we bring this all together? How do we actually try to address that problem? I mean, again, you don't necessarily have to answer it, but how do the two sort of work together again? And in some cases, maybe talk a little bit about the future of the technology. Where do you think this is heading? Is this technology still going to be useful in 10, 20, 30, 50 years? Okay? And then the last part, and this does not count towards the page limit, but just list your sources. You know, you're going to do some research. I imagine for most of you, the sources are going to be websites. Try to make sure that they're verifiable websites. Okay, what does that mean? Wikipedia is not a valid source. Okay, I think Wikipedia is a great starting point. If you want to go, so like for GPS, I certainly went, when I was preparing this unit, to the Wikipedia page for the Global Positioning System, and I gave it a quick go. But then what you'll notice at the bottom of every Wikipedia page are usually a list of references. Use those. Look into those. Okay, so things that are quote-unquote trustworthy. Usually things that end in .edu are pretty trustworthy. Again, some people are crazy. .edu is usually okay. .coms, if it's not particularly, suiting their bottom line and their interests, can be really good sources, especially if it's a news agency. Okay? So try to use your best judgment to make sure your sources are verifiable and good. Certainly if you want to use books or journals or magazines, that is completely 100% okay. The only other restriction that I make is all the references you use must be in English. Okay? Because sometimes I might want to go, your paper inspires me and I want to go learn more and I want to go check the reference, and I'm sorry, I only speak English. There was a time when I used to speak Spanish, but that was a long time ago, so we're just going to limit it to English. Okay. And so at the minimum, I want you to use 3 or 4 sources. I don't really care on the style that you use for doing your references. If you want to use MLA, that's fine. You want to use APA, that's fine. Just pick one and be consistent. What I do require, though, and sometimes this needs a little bit of modification, is if it's a website, you've got to include the title of the page, URL, the date accessed, and the author if known. Okay? And so please make sure you provide all of that information in there. Any questions on sort of that layout, outline, format? Does this seem to make sense? Okay. So here's sort of to come back to your question, target your paper between 3 and 4 pages, double-spaced, 12-point font, 1-inch margins, not including the references. You can read that, the rest of it. And just a note, if you've got some figures or some illustrations or some graphics or something, if it spills onto a 5th page, that's fine. But in the absence of graphics, you probably shouldn't be going onto a 5th page. I will also put out there, knowing that we've got to grade all these things in a relatively tight time frame, I stop reading after page 5. If your text goes on to page 6, it will not get read. Because I just have only so much time to actually get all of these read and returned to you in a time frame. Okay? So, different milestones. We've already sort of discussed this choice of technology, but this is where we are now. What do you want to discuss? What's your technology? Why do you want to discuss it? What math concepts do you think you're going to bring in? And just as a note, this is not an ironclad contract. The technology is sort of an ironclad contract. You tell me you want to discuss search engines. Again, that's a disallowed topic, so we're going to do that in class. But if that's your thing, you probably shouldn't deviate from search engines without contacting me first. If you said for your math concepts, oh, I want to talk about search engines and I want to tie them in with logarithms. Okay, so you're writing the paper and you realize logarithms isn't the best math concept, but for your problem statement, there's a better one. Maybe, I don't know, coordinate systems is better for search engines. Feel free, that's fine. Okay, so don't think that when you put this in there with those math concepts and what do you think you're going to do, if there's some subtle changes, that's totally fine. If the technology changes, please send me a note and reach out to me. And that might happen, and that's fine. So yeah, so we've already discussed that. Again, you've got a week to work on that, and then within a week I will get you sort of my comments, whether it's approved. Sometimes I'll put like it's provisionally approved, and I'll give you sort of just not so much a warning message, but just a be careful about this, usually because it's a topic that people have used a lot in the past, and I've sort of seen a lot of common problems sneak up, just to give you some pointers and some advice on moving forward. And then in a very small number of cases, there might be a problem with it, and I'll say actually not approved, please try again. Okay? But again, you'll get credit for the choice of technology for turning in something on time that answers all of the questions. Even if it's not approved, you'll still get the full credit for doing that. Okay, so then moving on, we've got the first draft. As mentioned, it should be a good faith submission. So this is going to get turned in, it's going to go to your peers. What does that mean? I am not necessarily going to grade your first draft. The TAs are not necessarily going to grade your first draft. We might flip through it just to sort of, again, make sure it's a good faith submission. But what's going to happen is it's going to get distributed to your peers who are then, they're going to give you the feedback. What do you think I mean when I say good faith submission? I don't want to actually have to put a rigorous definition on the slide here. Right. So basically, I'm going to recap your words here. It was a serious submission. You didn't just sort of write something down at the last minute and turn in a page of text because something was due at whatever time on October 30th. That's exactly right. So what I want to see is, were all of the components there? Did you actually put in more or less a full draft? Did you have all the references? And was this fleshed out? If parts are missing, believe me, we'll notice. And then we'll evaluate. So for this first draft milestone, again, 15% of that total process grade was just did you turn something in. So I'll give you the 15% even if it's not a good faith submission, because then it went out for peer review and you can get comments from your peers saying, wow, where's the rest of your paper? Okay. The other 25% is going to be, was it that good faith? And so long as it was deemed to be good faith, you're going to get full credit. There are a few other little guidelines. So one of the things, when you turn in this first draft, and this is going to be a weird instruction for a lot of you, do not put your name or your ID in the first draft. Why do you think I might request that?
Since we're doing a peer review, you don't want that person to know exactly who wrote this, so that I can go to them and tell them, oh, you did this one, you did this one.
Exactly, because it's going to go through peer review, and I want the peer review to be double blind. Which is to say, through the Blackboard system, whoever gets your paper will not know it's your paper. They are going to know you as author 1 or author 2 or author 3 or author 4. And so if you put your name and ID in the paper, you've just blown anonymity. So I'll remind you of this when we get close, but do not put your name and ID in the paper. We, being me and the TAs, we will know you submitted it. We can see everything inside Blackboard and can see who submitted what, so we will know. And it works fine electronically. I'm just also going to give you the notice right now, and again, we'll talk about this more when we get closer to the end of October. The peer review system inside Blackboard it gets better every semester. It is extremely rigid, and it is extremely non-forgiving. And so what I mean by this, on a lot of the homework assignments, if you make a mistake and realize you need to change the document that you uploaded, you can send me a note or send the TAs a note, and we can authorize a resubmission and let you upload a second document. The peer review system is not forgiving. Once you upload that first document, there's nothing I can do to override it. So make sure you do it. Make sure you submit the right document when you upload it. The deadlines are extremely rigid. When we say the peer review is due at whatever time on October 30th, if you submit 1 second after that, it will not go through. And your paper will not get sent out to your peers, and there's nothing I can do to override that. Okay? So again, I'll reemphasize this, but make sure you're very cognizant of following the instructions because I have very limited ability to override any mistakes. Okay? But there's that. Any questions sort of on that first draft? Okay. So then, once that's turned in, as I mentioned, we'll go out for this week of peer review. You'll have I think it's about 10 days to do this, to read 4 of the papers and provide feedback. And it's going to be set up, the very last page of this document that we're getting close to is the actual rubric for the paper. What are the different scoring criteria? And you're going to have basically that rubric programmed into Blackboard, and you can give the scores and give comments as appropriate to the author on their paper to see sort of where do you think they fall on that rubric. Why do we go through the peer review? Why do you think this is an important component of this project? Anybody have any ideas? Is it because I think you've got nothing better to do with your time? Yeah.
Probably 2 reasons.
Yep.
One, to make work overall better. Another, to make us learn more about the subject in general by reading other people's papers.
Exactly. So there's 2 things. Number 1, it dramatically improves the quality of the final drafts because you get some preliminary feedback, which then raises everyone's score, typically. And number 2, you're going to learn something out of it. You're going to read these 4 other papers, which are probably going to talk about technologies different from yours, and you're going to learn something. But then with regard to your own paper, you can see what worked or maybe what didn't work for other people, and that might give you some other ideas on how to make your paper, again, a little bit better. Okay? So that's really the reason here. The sort of the third reason that wasn't mentioned is that throughout your time in college and throughout your career, you're going to be asked to provide feedback to other people. They're going to give you something and say, what do you think of this? Or how do I improve this? And it's a skill to be able to give constructive criticism. You know, a lot of times people hesitate to be critical because they don't want to sound like a jerk. That's missing the point. It's perfectly okay to be critical, but you want to be constructive in that criticism. If I say, oh, well, your problem statement wasn't very clear, was that really maybe a jerk comment to make? Or is that going to be helpful to you when you get that comment to know that, oh, I need to go make that problem statement more solid? Okay, that was constructive criticism. What's not constructive is saying, wow, your problem statement was really awful. That's sort of veering into the realm of being a jerk. Okay? And so what we want to be able to do is to practice, how do we give constructive criticism? It's perfectly okay to be critical. How do we make that useful to the person? Well, I would say who's asking for it, but in this case, for the person who I'm telling them to ask for it. Okay? And so that's what we're really going to go do. So it sort of gives you a little bit of perspective. What did other people do? You'll learn a little bit about their topics and get to practice working on the criticism and constructive criticism. And so what I've got in here, I'm not going to read through all of these points, but what I've assembled here is a list of common problems that I've seen in the term paper over the semester to try to give you some idea and maybe some words to help articulate if you think there's something maybe a little bit off about the paper, give you some ideas of what commonly happens. What I have found over the semesters is that the peer review is actually remarkably accurate at finding sort of big problems in the paper. If there's something structurally wrong or from a big sort of content side, the peer review is on that, no problem. Usually 3 out of the 4, if not all 4 of the 4 reviewers picking up on that problem and trying to give you feedback. And so what I'm trying to do with this list is to give you the words to articulate what those problems are, maybe with a little bit more precision to the author, so that they can improve their paper before it gets turned in for the final grade. So in time, read through those now as you start to plan out your paper, and certainly remember this list when we come up to the peer review. The one thing I just want to mention here, this last bullet point, is a lot of times images aren't properly used. Do not include an image just because you think your paper needs eye candy. Okay? That's really distracting when someone's trying to read it. Moreover, even if the picture has use or relevance, don't just put the picture in there and never talk about it. If you're going to put a picture or a figure or something in your paper, make sure it's referenced in the text. Why is that picture there? What are you trying to show with it? And of course, given the nature of this class and this assignment, I don't necessarily expect you to make the picture or the figure or the diagram yourself. If you take it from another source or use it from another source, what else do you need to include with that picture? A citation. Yes. That gets forgotten in a lot of cases, and that causes a lot of problems. Okay, and so then once that's done, the last milestone, you're going to turn the final draft. Some combination of David and I will read through those and get you comments, and that's sort of the end of the project. Before we go into the rubric, does anybody have any questions about this overview?
So submit both drafts to Blackboard, right?
Yes, both drafts will be submitted through Blackboard. There will be 2 separate portals. There will be one for the peer review, which we'll talk about in October. Then there will be a separate one for the final draft after the peer review.
Will the final draft be PDF too? Can I get like a Word document?
All submissions should be PDF. Yep. So the reason for that is sometimes Word has different versions, and something can get screwed up between the versions. Maybe not everyone has Word, depending. I mean, I know the university has a site license, but if you're running a Linux box, maybe you don't even have Word because there is no Word for Linux. PDF is just a completely portable document format. That's what PDF stands for, portable document format. It works across all systems with pretty much no issue. And so that's why I go for PDFs. Yep.
You mentioned looking at Princeton University Press
Yes.
to find ideas. Does the university have copies of those?
So that I actually don't know. So the question was up at the top. I said you might look at this Princeton University Press book for some ideas. I have a copy of it in my office. You're more than welcome to come and see during office hours. The university might, I haven't actually checked the library's website. The book's only about 2-3 years old, so it's possible they may or may not. with regard, the book is very detailed, and it's sort of this big tome. Really, just the table of contents is probably what you're really looking for. That is freely available online, and I actually included a link to it. If you go to that What is Applied Math folder, there's a link, or even maybe just the actual PDF document itself, and you can see it there online.
The reason I asked is I found something in the table of documents,
Okay.
in the table of contents that I liked, and
Okay.
I wanted to know what else the book had on it.
Sure. So if that's the case, then yeah, you can check the library and see, and if they don't have it, just swing by my office during office hours sometime. I'm happy to show it to you. Yep. Okay. So, other questions generally? All right. So then, rubric, I know it's sort of a big table here. There are basically 6 categories that we're going to be using to assess your paper. One of them is formatting and length, which is basically, did you follow all the formatting and length instructions? It's the right length, 12-point font, 1-inch margins, double-spaced. You did not include your name or your ID on the first draft. Whatever. Those should, relatively speaking, be pretty easy points. There's going to be one section for the technology. How is your discussion of the technology in and of itself? Did you give a good historical backdrop for the technology? Good context. Talk about its uses, how it works a little bit. And that'll be on the same sort of 4-point scale. Another rubric item for the actual math concepts. Were your math concepts introduced well? Did you talk about them clearly? Were your math concepts actually math concepts and not physics concepts? Okay, so for one instance, in our GPS unit, what do you think that speed distance time was? Was that a math concept or a physics concept? That's a physics concept. Typically, a good rule of thumb for determining is something a math or a physics concept, or engineering or anything else, is it an equation? If all you have is an equation, you're going to tell me, oh, well, this variable means this, and this variable means this, and this variable means this, that's almost a dead ringer that it's a physics concept. Okay? The math concept there would be an equation, and I'm just going to tell you right now, an equation is too trivial to use for your math concept. I think we can do a little bit better than that for this assignment. If you've got questions, please certainly let me know. And again, I gave sort of a list of a whole bunch of math concepts up above on the slide. But don't wait until the last minute to realize, oh no, I think my math concept might be a physics concept. Come talk to me early, and we can do some brainstorming. Okay. So sort of then weighing those two different question.
For the math concepts, is it better that we focus on one more, or should we use more than one?
So the question is, should you have just one math concept or more than one? To some extent, that depends on what you're trying to do. In a lot of cases, one is certainly sufficient, and you've got a nice discussion of one math concept. That'll get full marks. Depending on the problem statement that you ask, depending on the technology, maybe you actually need to use 2 where you don't really go full depth into either one, but you need to bring a little bit of both of them. That's also completely fine. Okay? And so that's going to depend on what your problem statement is and what your technology is. But yeah, using one or multiple is fine.
You said that we're filling out a rubric on Blackboard.
Yes.
Like for everyone's thing. Are we getting a grade like based on what they put on it?
So that's a great question. I meant to answer that. So you're going to get a score from the 4 people that peer review yours to sort of give you an idea. Those scores will not be reflected in your grade whatsoever. The way the peer review factors in your grade is, did you participate in it? And then you have the prerogative after those peer reviews come back to you. You can completely disregard what they say and just turn in your first draft as your final draft. That's fine. Or you then have the chance to use those comments and maybe try to improve your paper a little bit. But yeah, the scores you get from your peers will not factor into your grade in any way, shape, or form. They're for your reference and only and to help you better your paper. Okay? So then we sort of have, for those 2 contents, we've got the technology part, we've got the math concepts part, another line item for how well did it all come together. Since this course isn't applied math or modern technology, it's applied math and modern technology, how well did it form a cohesive discussion? And again, this is where the problem statement usually really helps at forming sort of what is that overall discussion. Line item for just writing quality and or grammar. You can take a look at that. If, again, this is someplace where the Writing Center can usually help. And then references, again, I want to see at least 3, and so long as they're all cited properly, again, meaning URLs included, data access and all that, 3 points, and you can see sort of how the rubric goes down from there. That's about all I have to say right now for the term paper. Does anybody have any questions on this? Okay. Then this document is already posted on Blackboard. Please take a look at it over the weekend, over the next week. Work on putting together your choice of the technology. Post any general questions you might have to the Blackboard discussion page. I believe there's a term paper discussion board that just completely dedicated for term paper issues. Post it there. One of us will get back to you as soon as we can. If it's something a little bit more specific to you, feel free to send me an email, and we'll go from there. Okay, so the next thing I want to talk about is just some notes on citing other people's work. And the reason I do this, the first time I taught AMS 103, there seemed to be a lot of confusion when I got to the final drafts about how to cite things. And what this ended up resulting in were basically a whole bunch of minor cases of plagiarism. Not because I think most of the students had some sort of malicious or nefarious intent of saying, I'm trying to rip off this website and claim it as my own work, but just because they didn't cite things properly. Okay? And so I want to spend just a few minutes to talk about how do we cite things, because this turned out to be a much bigger problem than I would have anticipated, and I want to try to help you and learn how to do this correctly, because this is important. Again, whatever you're going to do, you're going to be working with things that other people produce. And so just for a couple guidelines, I'll let you read the first paragraph on your own. One thing is to quote sparingly. You know, one of the things that will happen is, this usually happens at least once every semester, I'm going to get a term paper where 2 of the 4 pages is all quotations from different websites. It's cited correctly and all that. Do you think that really warrants full credit? No, because what did you actually do besides go find a bunch of websites and copy a bunch of text in and put it in quotes? Did you really do anything other than just sort of compile this list of quotes and put enough text to string it together? And that forms a problem. The bigger issue is when you're quoting is you want to use your own words. A lot of times the source that you're using may not talk exactly about what you want. It's either going to leave out a few details or it introduces some details that maybe are superfluous to your discussion at hand. Put it in your own words, and that way you're tailoring the information for exactly the purpose you're trying to solve. Okay? And remember, if you're quoting, it's not enough to put the text in quotes. You also need a citation. Where did the quote come from? Okay? One of the big issues that we had the few years ago is people were trying to quote, and they forgot to put quotation marks around the quote. All they do is, here's the sentence and a citation. Is that plagiarism? Yep. Because without the quotation marks or some other way to identify it's a quote, you're claiming these are my words. Okay? And so, again, the general rule of thumb in my mind is just quote sparingly, if at all. I typically try not to quote things, period. And it just avoids a lot of those issues. And so number 2, if you're not quoting, a citation to the outside work is sufficient, and ideally you've got 1 citation to the source for every main point that you use. So if you go to one website and it actually has 3 good main points, then at some point you're going to have 3 references in your document to that. And then on the reference cited page, it's either number 1 or here's the last name in the year, whatever site key you're using, and that appears 3 times throughout your document. Number 3, just as a matter of style, taking a source, putting a citation to it, and you're not necessarily directly quoting it, but you're doing sort of a minimal paraphrase job where you sort of reorder the clauses in the sentence, you change a couple of the verbs to different synonyms and all that. Is that technically plagiarism? No, not really. Is it a good idea? No, not really. Why is that a bad idea, generally speaking? Well, number 1, you're not really coming up with any new ideas. So from an academic perspective, that's not really a great idea. More than that, what sort of is the problem here? What comes out, do you think it's good or it's fun to read and good to read, or does it come out like looking like trash? It usually comes out looking like trash. And so at that point, now you're damaging your credibility with your reader. Because all of a sudden you had really good discussion, really nice discussion, and a whole paragraph of, where did this come from? Does this person really know what they're talking about? Because these sentences, yeah, I guess that is technically correct English, but who talks like that? Okay? And so typically, if you've got this great source, put it away. Don't even look at it while you're writing about it, and just try to put it in your own words. Don't do this paraphrasing game. It just comes up with sentences that just read terribly. Okay, so if you have to quote, as we've already said, make sure you make it clear that you're quoting. If you've got just a sentence or maybe a fragment of a sentence, just put quotation marks around it and then a citation. and this realistically should not happen on this assignment, but in general, if you've got a bigger quote, where maybe it's a couple sentences, again, in a 4-page document, you should not be quoting multiple sentences at a time, period. If you don't want to use big quotes, you can actually put it in a block, like make it its own sort of paragraph, increase the margins a little bit, and set it in its own thing. And that is also a common way to denote that this is from someone else's work. Here's the citation. It's a direct quote. And so you can see here, here's sort of a multi-sentence thing. This is a block. This block of text is an example of a large quote in its own block. There is more than one sentence, blah, blah, blah. And then as we said a moment ago, images or any other multimedia that you include must have citations to their original sources. Okay? Don't just drop the image in. Just like any text or ideas you use, you need to say where you got that from. Okay, so what I want to do, just in a real few minutes here, is go through a couple examples, just sort of looking at, here's the text that you see, is it plagiarized? And so what we're going to do is we're going to take one sentence from our Trimble tutorial, which I've got, notice, in quotes here. The Global Positioning System, GPS, is a worldwide radio navigation system formed from a constellation of 24 satellites and their ground stations. It's a pretty tight sentence. It's informative. I'm going to assume it's technically accurate because we're going to assume Trimble is a valid source. Okay, so you're now writing your paper on GPS, which again is not really an allowed technology for you, but for the purposes of this example, great. And you want to use this piece of information. So in your paper, you write exactly this. The Global Positioning System, GPS, is a worldwide radio navigation system formed from a constellation of 24 satellites and their ground stations. Is that plagiarism? Yes. Why is it plagiarism? Number one, there are no quotes. Number two, there's no citation. That is what I would consider like a malicious or nefarious form of plagiarism, because you just directly copied and pasted off of Trimble, put it in your paper, no attribution whatsoever. That is most certainly plagiarism. That's an easy case to find. Okay, so now you have in your paper, the Global Positioning System, GPS, is a worldwide radio navigation system formed from a constellation of 24 satellites and their ground stations, Trimble. Is that plagiarism? Yes, because again, it's a direct quote. No quotation signs were routed to indicate that those are not your words. Okay. The Global Positioning System, GPS, is a, quote, worldwide radio navigation system formed from a constellation of 24 satellites and their ground stations, unquote, Trimble. Is this plagiarism? Nope, that's perfectly fine. You've given a source. You said, hey, I got this from Trimble. You put quotes around it to say, these are words I took directly from them. Life is good. Again, don't do this all that often, but for sort of a technical thing like that, I think it's fine. Yep.
So like if you use a quote and like we put it, like we don't put it there, but we put it in the bibliography, is that fine too?
No. So if you've got a quote, putting the reference just in the bibliography is insufficient. You need to then make reference in your paper to say, and so this is where you see it's actually just like this Trimble in brackets. You don't need the full reference there. You would then look down into the bibliography to say, oh, well, that Trimble reference is, here's the website, there's the date it was accessed, which, again, notice here in the footnote, I make explicitly, oh, look, that date accessed is missing. And then you can find the full details there. That way it's not taking up a whole bunch of space in your paper with the details, and sometimes you're going to reference it more than once, and so it's not just getting really repetitive. Okay? But yeah, you need, even with the quotes, you need that citation right there to say which of the sources did it come from. Yep? So most styles anymore don't use footers for references. They'll actually have like a works cited section at the end of the paper, and that's become more the preferred style than doing it in footnotes. Okay, so the next example. The Global Positioning System, GPS, is a system of radio navigational tools that span the world that consists of 24 satellites acting as a constellation and also their ground stations, Trimble. Is that plagiarized? I mean, you can read the answer and it's unclear. What's the issue with this sentence? Well, it's way too similar. That was a really cheap shot at paraphrasing. And if you think that sentence was hard to get through, try reading a paper that's 4 pages of that. Some of you on your peer reviews will. I hope it's not you. It's hard to get through because how many times do you have to read that sentence to figure out what it's actually saying? For me, it's about at least 3 times, and I wrote it. Okay. So now we have the Global Positioning System, GPS, consists of 24 satellites and some ground stations that form a planet-wide navigation radio system. Is that plagiarized? This one, I'm going to go with probably yes. Number one, there's no citation to the Trimble website, but here, this is where sort of paraphrasing is a gray area, because this is certainly paraphrased, but very, very, very narrowly paraphrased. The bigger issue is that there's no citation to Trimble. But just for the analogy, you can see where that goes. And then lastly, the Global Positioning System, GPS, consists of 24 satellites and ground stations that use radio waves to accurately determine locations anywhere on Earth. Trimble. Is that plagiarized? Nope. Takes the information, writes a completely new sentence, doesn't reek of paraphrasing, and there's a citation. Okay, so I know this is really boring for the last 10 minutes to work through this, but again, this has been a really big problem in previous semesters, so I want you to have the tools to succeed and to know what to do and have some resources available to you. Certainly, by all means, at any time during the semester, working on this when you're working on your paper, revising your paper, looking at the papers that you're reviewing, if you've got questions about plagiarism, paraphrasing, all that, please come and talk to me. I want to help you work it out. Okay? Any questions on that? Okay, then that sort of ends what I wanted to say about the term paper today. And what I think we want to do now is sort of jump back over and look at this big example. So we'll remember from last time, at the very end of class, at the very bottom of the notes, we had this little example. Let me make this slide just a little bit bigger here for a moment, where we can finally put together everything that we've learned about the GPS unit. And I gave you here a couple satellites. There's their location and latitude and longitude, and there's the time it took the radio signal from that satellite to reach you. Some useful information. So I gave you the speed of light in units that make this not that difficult. Again, this is a math class, not a physics class. I don't think it's really pertinent that we have to do a whole bunch of unit conversions. The radius of the Earth, we'll just assume is 4,000 miles, and the satellites orbit at 12,500. And we'll also assume for the purpose of this project, or for this problem, all of the clocks are synchronized. So did anybody make an attempt at this problem since Monday? Okay. Oh, that's one hand more than I was expecting. Cool. Anybody want to take just a guess? It's a city in the continental US. You've got probably, what is it, a 1 in 10 trillion chance of being right? Is it a famous city? No, but it has a fun name. What was that? It is not Sex, Pennsylvania. I kept it above the belt. It is not Tallahassee, Florida. That's not really a fun name. It's just fun to say. Oh, what do I mean by fun? We'll get there. Okay, so how do you think we can go about dealing with this problem? What do you think we should do? What do we need to do? Again, I know this is sort of a big, complex problem. That's why we're going to work it out together in class. But what do you think we need to do to address this? Any thoughts? Yep. Okay, so we need to maybe convert the latitude and longitude in the coordinates, these locations of the satellites, back to Cartesian coordinates. Okay, I think that's a really great place to start. So what you might recall, if we go back up in the notes here, a couple slides, there was sort of this summary. And so, when we look at how GPS works, there were these 6 steps. So one was get the locations of the satellites and measure the signal transit times. Are we already done with that step for our problem? Yeah, that information was given to you. We know the locations of the satellites. Here's their latitude, longitude, and altitude. And we have those transit times. Okay, step 2. Locations of the satellites will probably be in spherical coordinates, altitude, longitude, latitude. Convert them to Cartesian. Why do we need to do that? Why can't we just leave them in this altitude, longitude, latitude form? Yep. Okay, so your answer was there's no way to find the distance. That's not entirely right. You can do the distance formula in spherical coordinates. It's disgusting. It's just a lot easier to work with Cartesian. So we're going to go to Cartesian coordinates because when we want to calculate the distances, that distance formula that we had required Cartesian coordinates. We needed x, y, and z. Okay? So we convert them over. And once we know that, we can calculate, using the transit time, our distance from each satellite. Again, just using our speed, distance, time formula. Okay? What we can then do is construct that system of equations where each satellite is going to give us an equation. It's going to tell us we're somewhere on the surface of a sphere with that satellite at the middle. Okay? We can do that for all of the satellites, and now what we can then end up doing is trilaterate our position and say, well, those spheres are going to intersect at some number of points. If we only had the one satellite, we know we have to be somewhere on that sphere. If we had two satellites, we can narrow down our location to a circle. When we have the three satellites, we can get it down to 2 points. And what do we use to distinguish between those 2 points? The fact that we're on the surface of the Earth. One of them is going to be on the surface. One of them is going to be either floating up in space or somewhere down in the mantle. We'll assume we're not in the mantle or floating up in space. Okay? And so from that, that's step 5. Then we can trilaterate the location by solving the system of equations. And then last, what do we get out? Once we've solved that system of equations, we've done this trilateration, what do we have? Well, we know our position, but in what form? It's in the Cartesian coordinates. We're going to get it in x, y, and z. And is that how we want to discuss locations on the surface of the Earth? No. We need to convert it back to latitude and longitude. And then we can talk about our location. Okay. So that's basically the process we're going to work through. Let me come back down here to get the numbers. We'll make this a little bit small again just so that we can use the smartboard here in a way that's not entirely stupid. Using a smartboard stupidly is one of my best skills. Okay, so the place we need to start, hold on, I gotta recalibrate the board here. I noticed a minute ago it was not working right. When I try to start handwriting, that's gonna be a problem. Sorry about that. Okay, so what we can do is work on converting these satellite positions from spherical to Cartesian coordinates. Oh, come on. Okay. I'm just going to make this full screen because I know that's going to work. And then I've got the numbers on my page here, and we'll just convert back and forth. Okay, so we need to convert satellite locations to Cartesian coordinates. Okay, so satellite 1, latitude was 52.59 degrees north. Longitude was 126.09 degrees west. And the altitude was 12,500 miles. Okay, so are these actually those three spherical coordinates? Are these the r, theta, and phi coordinates that we talked about? No, not quite. How do we go about converting them? So let's say we want to get the r. What was r in our spherical coordinates? Yep. So it's the radius. It's our distance from the center of our sphere. Where do we want to put the center of our sphere when we're talking about this GPS system? Where do you think we're going to put the center? The center of the Earth. Okay? So the question then, when we want to look at getting r, that's now the distance from the center of the Earth. Is altitude the distance from the center of the Earth? No, altitude is distance from the surface of the Earth. So to get the total distance, we need to add what to that altitude? The radius of the Earth, which is another 4,000 miles, because that gives us the distance from the center, which is where we're defining that 0, 0, 0 point to be. Okay? And so to sort of draw the little picture here, there's our 4,000 miles. and there's a satellite floating up there, and obviously that picture is not to scale. Okay? So that's one of our 3 spherical coordinates. How do we go about getting the next one? Let's do theta. So theta was this azimuthal angle. Did that relate to latitude or to longitude? That was our longitude. Okay? And do we remember the convention? So we know the longitude was 126.09 degrees west. Does that correspond to a positive or negative theta? Negative. And was there sort of any problem in converting between the two, or could we just use the number straight up? Just use the number straight up, right? Because we just said 0 degrees is the prime meridian, negative values are western hemisphere, positive values are eastern hemisphere. And so we know that theta is going to be minus 126.09 degrees. And so then for our last angle, we have phi, which remember, now this is that polar angle measured from the North Pole. Okay? So if we're at 52.59 degrees north, we're in the northern hemisphere. So do we expect this angle to be between 0 and 90 degrees, or to be between 90 and 180 degrees? It's going to be 0 to 90. Okay? What we found last time, and you can go review your notes, is that this angle was 90 degrees minus the latitude. Again, where north latitude was interpreted as a positive number, and negative, and southern hemisphere was interpreted as a negative number. So we just need to take 90, subtract off our 52.59 degrees, and that leaves us with, actually I don't have that number written down. Yeah, it will be 37.41. Okay, so now that we have those 3 spherical coordinates, is it pretty straightforward to go to Cartesian? Yeah. Okay, so to those of you that are glazing over right now, because there's a whole bunch of equations, number 1, this is probably the mathiest lecture we're going to have all semester. And number 2, I promise you there's a fun answer in 20 minutes. Just bear with me. Okay, so to convert finally to Cartesian, what we can get was we had x was equal to r. Was it cosine or sine?
X is sine of phi, cosine of theta.
Yep, thank you. This is why this equation will be given to you on the quiz, because clearly I can't remember it either. And then lastly, z was equal to r cosine phi. I think that's right. You can check your notes. Okay. So now all we have to do, since we found those r values, we found the phi value, we found the theta value, we can just substitute in, and we can get now our x, y, z coordinates. Okay? I think in the interest of time, I'm just going to write the answer down, because we can then move on to what comes next. But you should definitely try plugging this in and verifying what's going on. And so we're going to get that x is equal to minus 5904.68 miles. Y ends up being minus 8100.31 miles. And z is 13106.1 miles. Okay. So how does this work now if we want to convert the location of satellite 2 to Cartesian coordinates? What do we need to do? Exactly the same thing. And what about satellite 3? Exactly the same thing. So this starts to get a little tedious, right? Yes? Okay. So what we're going to do is I'm just going to write down what those coordinates are, knowing that we just go through the exact same procedure again. And so we'll say x2, so this is the x coordinate for the second satellite, is minus 4076.16 miles. I'm going to omit the miles. All of these are in miles. Its y coordinate is minus 15910.2 miles. And its z coordinate is minus 1581.45. And then last for satellite 3, sorry, it's 8944.94 miles. The y is negative 13201.7. And the z is 4237.12 miles. Okay, so that's sort of, there's that step, what was I think? That was step 2 in that 6-step process. So we've now got all of our satellite locations. What's the next thing that we need to do? Should I bring that slide back up? Okay, convert it back. Convert what back? Okay, we already know the spherical coordinates for these, though. So is that really going to help us get any closer to the solution? Not quite. We are ultimately going to have to convert something back to spherical, but we're not quite there yet. So it's a good thought, but just let's hold off about another 10 minutes. Okay? Yes? Right, so we need to calculate the distance from each satellite. So remember, what we needed to know was how far are we from the satellite and what is the satellite's position. Right now, all we actually know is how long did it take the signal to reach us from the satellite. Okay? So we need to get those transit times, or the distances. So we knew, if we were to go back to that table, the first transit time was 70, for the first satellite, was 70.7286 milliseconds. And I gave you in the table that the speed of light was this 186, yeah, 0.282, not quite miles per second, miles per millisecond. What was it? Oh, yeah, it's 186, excuse me. Okay? And so, how do we calculate that distance from the first satellite? Yeah, we've got our distance equals, or distance speed time relationship, where distance is just equal to speed times time. So we can plug in our 186.282 miles per millisecond times our 70.7286. And the distance that we end up getting is, of course, I only have the distance squared written in my notes. What would this be? 13,175 or so miles. Okay. And again, we can go through and we can do that for satellite 2 and satellite 3. And this polishes off step 3 from that 6-step process. So now, after we're done doing that for all of the satellites, let me actually go back if you're trying to still copy down while I talk. Now we know what's the location of the satellites. We know our distance from all of the satellites. And so we can now set up that distance equation for each of the satellites to help us narrow down what is our location. And so basically, the way this works is we know that for each of the satellites, we have some distance. We can call that di. I'm going to go ahead and square things here just to make it a little bit nicer. But that's going to be equal to our position x minus the x position of that satellite squared. Plus the same thing for the y coordinates. Plus the same thing for the z coordinates. Just as a hint, if some of you have already looked at the homework assignment and seen number 5, you'll notice that that's a very stripped down version of this problem where I'm going to give you, here's a couple places where you could be, and here's some satellite information. Which of these places could be your position? And it's, as the problem goes on, I'm going to add more and more information, like maybe telling you, you are on the surface of the Earth. Does that help narrow it down? So what that sort of amounts to, if you wanted the hint, was sort of setting up an equation that looks something like this and doing a little bit of substitution to see, does everything work out right? I don't want to say much more than that. I don't want to spoil the fun. But that's, don't make problem 5 harder than it needs to be, would be my hint.
So it's kind of like this. So problem 5 is basically kind of like this.
Yep. And that's why we're working the example today, knowing that this example is much more complicated than what you have to do in problem 5. Okay, so what we end up getting from satellite 1, we can plug in our distance from last time, and when we square it, what we get is some really big number. So it's 1.662 times 10 to the 8th. Okay, so that's, what is that? Something around 166 million miles squared, something like that. And then we end up getting, taking our values from last time, so we get x plus 5904.68 squared, because it was a minus 5904, as I recall. Yep, right there. A y plus 8100.31 squared plus z minus 13601.1, or sorry, 106.1.
Question, what's that variable next to 1.662 times 78?
Sorry, which one? The E?
No,
Oh.
the variable right next to the, like at the beginning before you...
This DI?
Yeah.
Distance.
Oh, DI.
Yep, distance from the ith satellite. So whether it's 1, 2, or 3. Yes, another question. So here it's actually going to be plus, or it's going to be the, so it's minus, but remember, these two distances, the locations were actually negative, and the minus minus turns into a plus. Yep, thanks for checking. Okay, and so what this equation tells us is whatever our position is, whatever our coordinates are, x, y, and z, they have to satisfy this equation. If they don't satisfy this equation, they cannot be our position. Okay? So likewise, we can go and we can create an equation like this for all three of the satellites. And at that point, we would need to solve that system. Now again, solving these systems of equations is beyond the scope of what I expect from you. So what would you do? Yeah, go to Wolfram Alpha, type in these three equations and say solve, and it would give you some solutions. In the interest of time, I don't want to type all of them in because that would probably take 5 minutes. What I'm going to do is just give you the answer. But again, go home and try to verify this. What we get after we do all three of those equations, and so this is that trilateration step. Step 4 was set up those equations, those distance equations. Step 5, we can do the solve. And so what we end up finding after all of that is done was that our x-coordinate was 309.354 miles. Our y-coordinate, our position, minus 2935.94 miles. And our z-coordinate is 2698.99 miles. Okay, so does anybody have a better idea where we are in the continental United States now that we know this position? No, that's kind of useless information from getting that perspective. So the last thing we need to do now is convert back to spherical, because we can get then our latitude and longitude, right? Okay, and so the way that this works, now do we actually care about all three of the spherical coordinates in principle? Yeah, we just need the latitude and longitude. Now, we're still going to need to calculate r to get there, but we don't necessarily care about it. So we're going to come back to get our latitude and longitude. And so to do this, we can have our spherical coordinates. So we get r, if we recall from last time, was square root x squared plus y squared plus z squared. We can just plug these three values in. And what number, more or less, do you think this should turn out to be? It's about the radius of the Earth, because we know we're on the surface of the Earth. And sure enough, you can verify. There's probably going to be a little bit of rounding error, so you might get something like 3999 point something or whatever. But this is essentially 4,000 miles. Good safety check to make sure everything worked okay. If this was something other than 4,000 miles, check your work. Yep?
Like how great would the error be if, instead like you realize that there's a mistake there?
So if this was, let's say, the question was how big could the error be before you realize there's a mistake? If you're probably within a mile, either way, it's fine. If you're more than a mile away, again, now given this problem where we said we're going to assume the Earth's a perfect sphere with radius 4,000 miles. In practice, the radius of the Earth, depending on where you're at, is going to be between about 3950 and 3975. So there you'd have a wider tolerance just adjusting for the actual altitude at that specific spot. Okay? All right. So then we can go to our second spherical coordinate. We had this azimuthal angle theta. And that was our inverse tangent of y over x. And now the thing we have to be careful about remember, this was that one place where we could give this formula, but there was sort of that caveat. And we needed to modify it a little bit if x was negative. So let's go back. Is x negative? Nope. So does that formula going to work okay? Yep. We can just plug in the numbers. And what we end up getting out is minus 83.9851 degrees. And I'm putting that much accuracy so that when we type these coordinates into Google Maps in a little bit, maybe we'll get close. And so what longitude now does this correspond to? It's negative, so which hemisphere are we in? We're in the western hemisphere, and how do we convert this over? Just drop the sign and put a W after it. Okay? So we now know our longitude. It's 83.9851 degrees west. And so lastly, we now need to determine this polar angle to figure out what is our latitude. And the way that this worked, so this was the inverse cosine of z over r. So we can take our z coordinate from the last slide, divide it by 4,000, take inverse cosine, and we're going to get a number that's approximately 47.5 degrees. I don't have the exact number written out here. Yeah. So z was it 2698.99 divided by 4,000, inverse cosine. And so this is now telling us the angle from the North Pole. Okay, but we want the angle from the, when we're thinking about latitude, we want the angle from the equator. So we could just do 90 degrees minus this, because those are going to be complementary angles in that sense. That's about right. I just had the final answer here in my notes. And so what we can end up doing then is saying that our latitude is 90 degrees minus phi. And when we put that through, we end up getting 42.4346 degrees north. Okay. So we now have our latitude and longitude. Does this still give anybody a good idea of where we're at? Anybody have an idea of what state this might be? It is not New York. What was that? It's not Pennsylvania, but you're getting closer. Ohio's even closer. Illinois is getting a little bit further away now. You've gone too far. Okay, so what we can do is we can come over to Google Maps and type in 42.4346 north and 83.9851 west. And so to answer your question, where have you been during this entire example? We can hit enter. And we can scroll out. Here's the name of the saloon in the town. It is called the Hell Saloon. So this whole time you've been in Hell, Michigan. With that, have a wonderful weekend. Please post questions, and we will start our unit on digital devices Monday morning. Thanks for your attention.